This is a lesson on acid and base basics. There are many definitions of acids and bases. The first one, proposed by a guy named Arrhenius, and his definition was that acids produce hydrogen ions. In other words, things that start with an H are an acid. Bases produce hydroxide ions. In other words, they end with OH. Now the problem with that is not all bases contain an OH. Things that react with an acid might have, especially ones with nitrogen in it, have no OH, but they still act like a base. So that definition is not very useful anymore. A better type was proposed simultaneously by two gentlemen, Bronsted and Lowry, and their definition was an improvement on what Arrhenius said. An acid is a proton donor. A proton donor loses an H+. That is absolutely no different from Arrhenius' definition. They both work the same way. A base, though, is a proton acceptor. If there's a donor, you got to have an acceptor. They gain an H+. The benefit of this is it explains the nitrogen basics or organic bases, and it talks about proton donor, proton acceptor. This is fairly analogous to redox reactions, where instead of donating and giving an electron, you're donating and giving a proton. Here's an example. If you have HCl mixed with water, you produce the hydronium ion plus chloride ions. Since the HCl goes to Cl minus, it has lost an H and it's become more negative, so it's lost a plus. So this has lost an H plus, therefore it must be the acid. The water, on the other hand, goes to H3O plus, the hydronium ion. It has gained an H plus. It's one more H and it's turned positive. Therefore, this water must be considered the base. So you have pairs. The HCl Cl minus is 1, and H2O and H3O plus are called conjugate acid base pairs. These always occur in pairs, so you're going to have two reactants and two products. And if you reverse the Cl minus, if you go from Cl minus to HCl, Cl minus is gaining a proton, so it turns into the base. So the acid will make a conjugate base. The base will make a conjugate acid, because if you go from H3O plus to H2O, it's losing an H plus. Another example, NH3, here's that nitrogen problem for Arrhenius. Reacts with water to form ammonia and OH. So it doesn't have OH to begin with, but it does produce an OH minus. The NH3 looks more like NH4 plus, so it has gained it. So this is a proton acceptor, which means this is the base. This is the conjugate acid, because if you go the reverse, it's that way. The H2O in this case then gives off the H plus and turns into OH minus, so that means it is the proton donor. So this is the acid in this case. If you have a weak acid, then you have a Ka. Remember, definition of a weak acid? It is partially ionized. It therefore will form an equilibrium. So if you have a generic acid, HA, plus, say, water, and water is a liquid, to form hydronium ions, plus some anion. Right over left, ignore the water because it's a liquid. So the Ka concentration of the hydronium ion times the concentration of the anion over the concentration of the acid. Some definitions and information that you need to know. Strong acids, again, ionized completely. There are 4 strong acids: HCl, H2SO4, HNO3, and HClO4. H2SO4 we're going to talk about a little bit later. There are weak acids, and these ionize less than 10%. Very few are that high. Most of them are 5% or less. So they're often much less for many, many, many acids. There are something called diprotic acids. Diprotic acid gives off 2 protons. An example, H2SO4. There are oxy acids, which means the proton is attached to an oxygen. Like HNO3. An acid that would not be an oxy acid would be like HCl. That would be a non-oxy acid. There are organic acids, which end with COOH if you see them in a formula. They also are, if you want to do a Lewis dot diagram, C double bonded O on an OH, and this is the acid. That's the H that will lose on that point. Another term you need to know is amphoteric. Amphoteric means it can either gain or lose a proton. A good example would be the hydrogen carbonate or bicarbonate, yuck. If you lose an H plus, it'll form the carbonate CO3 2 minus. If you gain an H plus, you'll form the H2CO3 carbonic acid, which doesn't exist. It'll decompose quickly. You can also have something like water that can self-protonate It's amphoteric. It can gain or lose an H plus like we've seen up above. H2O plus another H2O, remember these are liquid waters, can form H3O plus OH minus. The Ka would be H3O plus times OH minus over nothing because it's water, liquid water. So we call that a special K. Kw for water is the hydronium ion times the hydroxide ion. And that number at 20 degrees Celsius is 1 times 10 to the negative 14. Important number that you will learn to know. Example homework problem. H3O plus, concentration H3O plus is 1 times 10 to the negative 3 molar. What is the concentration of the hydroxide ion? Plug it into the equation. 1 times 10 to the negative 3 times the concentration of hydroxide, 1 times 10 to the negative 14th. Solve for the OH minus, 1 times 10 to the negative 11. That concludes this lesson on the basics of acids and bases.